Hi everyone. In this video we're going to be working on a 2015 AP Calculus B free response question. So what we're going to do is we're going to go ahead and get started with question number 5. It says consider the function f of x equals to that equation, where k is a non-zero constant. The derivative of f is given by f prime of x equals that equation. Now the first thing I'm going to notice is x, I understand, I know how to find x, I know how to work with x, but a k that's randomly given is probably something that's a little alarming in this question. So chances are, when we see this question, we're going to probably be given k at some point. Okay, so part A. It says let k equals 3, so that f of x equals to 1 over x squared minus 3x. What they did was, since this is f of x, they took that k equals 3 and they plugged it into there. This is how you got the equation. It says write an equation for the line tangent. Okay, so for part A, the fact that I see line tangent, I automatically think of this. Y minus y1 equals m parentheses x minus x1. That is the first thing I think about. Now the next thing I think about is I need to figure out x1, y1. But they told you at the point whose x coordinate is 4. Well, how do we find the y? Well, since we're given x, we can plug it into the original equation and find y. So I'm going to plug it in. F of 4 is going to equal to 1 over 4 squared minus 3 times 4. Work this out, you're going to get 1 over 16 minus 12, which equals to 1 over 4. That's my y coordinate. I'm going to go ahead and plug it back in. Now the next thing we have to find is the m. We have x1, we have y1. Well, how do we find m? We need a slope. We need a derivative. Well, our derivative they told us was f prime of x equals to k, but we already know what k is. We know that k is going to equal to 3. So we're going to plug in 3 minus 2 times x over x squared minus 3 times x squared. Well, what's x equal to? Well, we already know x is equal to 4, so plug in 4. F prime of 4 is equal to 3 minus 2 times 4. 4 squared minus 3 times 4 squared. And this is going to simplify to a number that gives you negative 5 over 16. And this is my slope at 4, 1/4. So then my next step is just plug everything in. So I'm going to plug it in. I'm going to get y minus 1/4 is equal to m, which is negative 5 over 16, parentheses x minus 4. And the last thing is, normally on an equation that deals with tangent line, you want to get y by itself. So I'm going to get y by itself. I'm not going to distribute anything. I'm just going to keep it here. Plus 1/4. And that is my tangent line. Okay? So let's move on to part B. Well, part B says, let k equal 4 so that f of x is equal to 1 over x squared minus 4x. All they did was they took that k equals 4 and plugged into the original equation like they did in part A. It says determine whether f has a relative minimum, maximum, or neither at x equals 2. And I think about it and I go, okay, min, max, how do I find that? What's the first derivative? Well, if it's a min or max, chances are if I plug it into my derivative, I should get a critical number, meaning it should equal to 0. So let's first determine that. So for part B, I'm going to plug in 4 into my derivative. But I'm also going to plug in x equals 2. But first, let's just plug in 4 into k. I'm going to get 4 minus 2x over x squared minus 4x squared. Well, they're trying to figure out if it's a min or max at x equals 2. So go ahead and plug in 2. So f prime of 2 is going to equal to 4 minus 2 times 2 over 2 squared minus 4 times 2 squared, which gives me 0 over, and it doesn't really matter what happens here, but if I solve it out, I'm going to get 4 minus 8 squared, and this is going to be 0 over 16. Regardless, you're going to get 0. Now the fact that I gave you 0, that's a critical number. Why is it a critical number? Because when I plugged in 2 into my derivative, I got an equation equal to 0. And whenever you plug something into your derivative and you get 0, that means it's a critical number. So what type of critical number is it? Is it a min? Is it a max? We don't know. But what we do know is this. Since 2 is a critical number, I can put down my number line. And then from there on, you pick numbers left and right. You can pick 0 and then you can pick 3. And you're trying to test this into the first derivative to determine if it's increasing or decreasing left and right of it. So when you plug in 0 into this, f prime of 0 is going to equal to, if you notice, if you plug it into here, and one of these things is 0 wouldn't be a good choice, and this is the reason why. Plug in 0, you see how you get on top, you're going to get 4, but when you plug in 0, you're going to get 0 on the bottom, which you can't have. So just erase 0, plug in 1. When you plug in 1, you're going to get 4 minus 2 times 1, so that's going to be 2 over, and at the end of the day, no matter what number you plug into here, the fact that it's squared, it's going to be a positive number. And 2 over a positive number is going to be increasing. Then I'm going to do the same thing for 3. I'm going to plug in 3, and that's going to be 4 minus 2 times 3, which is going to be, over, remember, a positive number because it's squared, and you're going to get negative 2 over a positive number, which means this is negative. Therefore, what occurred at 2 is a relative max. And then when it says justify your answer, you're going to say it goes from increasing to decreasing at x equals 2. Therefore, it's a relative maximum. So how was I able to find this? First thing is, in order to find a min-max, you have to first plug in your derivative, and it has to give you at least 0. Since it gave me 0, I know it's a critical number. Well, then I'm going to put on a number line, and I'm going to determine what's happening left and what's happening right. And I saw that it was increasing and it was decreasing, therefore it was a max at x equals 2. Okay? So then our next part of this question is going to move on to part C. Part C says, find the values of k. Find the value of k for which f has a critical point at x equals negative 5. Keyword, critical point. How do I find critical point? Critical point is the first derivative. So what I'm going to have to do is, I'm going to have to find my first derivative, which they gave me, and it wants me to find the value of k for when x equals negative 5 is equal to, what do we think? Critical number. Critical number is when the first derivative is equal to 0. So the first thing I'm going to do is I'm going to set, for part C, I'm going to set f prime of x equal to 0. Well, what's f prime of x? K, which I'm trying to find, minus 2x over x squared minus kx squared equal to 0. Well, what's x equal to? Well, they're telling us that x is equal to negative 5. So I'm going to take negative 5 and I'm going to plug it in. And that's going to give me k minus 2 times negative 5 all over negative 5 squared minus k times negative 5 equals to 0. And then when I simplify everything out, I'm going to get this. K plus 10 over 25 plus 5k squared equals to 0. And since they're looking for a critical number, remember, we can find critical numbers by saying the top equal to 0. If I set the bottom equal to 0, those are going to be my undefined points. So I'm looking for critical numbers which are going to be found by saying the top equal to 0. And then I'm going to go k plus 10 equals to 0. Solve for k. K is equal to negative 10. And that is how I find my answer. So how did I know how to do this? The key word was critical point. Critical point means I'm going to set my derivative equal to 0, numerator especially. And then since I knew that I had solved for k, they had to give me some x, which they did. They gave me x equals negative 5. I plugged it in. And I saw that k plus 10 is equal to 0. Solved for k. And that's how I got my answer. So far what we've worked on was 5 points. Now what we have to do is the last question, which is part D. Now part D is a tricky one if we're not so good with partial fractions. Okay? So moving on to part D. It says let k equals 6 so that f of x equals to 1 over x squared minus 6x. They took the 6 and plugged into the original equation. It says find the partial fraction decomposition for the function f. Then it says find the integral of that. So like you probably did in class, we have to first, when we do partial fractions, they want me to integrate this. But I can't integrate this because this is not, kids can't be integrated by substitution. So what I'm going to have to do is I'm going to factor this out. So when I factor this out, I'm going to get 1 over x squared minus 6x is equal to a over x. Well, let me first factor it over here so you guys can see it. X minus 6. So this is going to be a over x plus b over x minus 6. So what you're doing is you're taking one of the factors, putting it under a, taking the second factor, put it under b. Now what we're trying to do is we're trying to get an LCD so we can cancel out these bottoms. So because of that, I need an x minus 6 over here. And I need an x over here. So this is going to become 1 equals to a parentheses x minus 6 plus bx. Now I'm not going to write the bottom because this is just going to cancel out because I have an LCD. And that's my equation. So my next thing is I have to find a and b. So I'm going to do two scenarios. When x equals to 6, this is going to cancel out. So I'm gonna plug it into here. 6 minus 6 is 0. A cancels out. So I'm gonna be left with 1 equals 2. I'm gonna plug it in here. 6 times b. Solve for b. B is equal to 1 over 6. Now I'm gonna do the same thing now, but I'm gonna solve for the next one. So I'm gonna pretend, how do I cancel out b? I need x equal to 0. So when I plug it in, I'm gonna get 1 is equal to 0 minus 6 is negative 6. So therefore a is equal to negative 1, 6. Now your next step, once you have this, your next step is you're going to take this negative 1, 6 and this 1, 6 and plug it back in. So how does this look like? You're going to have this. The integral of, and then, well, I'll just plug it on top. Negative 1, 6 over x plus b, which is 1 over 6 over parentheses x minus 6. And they want me to find the antiderivative of this in respect to x. So now remember, what do you do with these numbers? You just take them on the outside. So this is going to become negative 1, 6 integral from 1 to x dx plus 1, 6 integral 1 over x minus 6 dx. And then this becomes one of those where it's just, how do you integrate 1 over x? Well, this is going to become negative 1 over 6 ln absolute value of x plus 1 over 6 ln absolute value x minus 6. And don't forget the famous plus c at the end. And the last thing is you're not going to have an answer like this because you see how these are the common terms in the front? The fact that this is minus, what I can first do is I can factor out a 1/6, but since just like we did in class, think about this. Take out the 1/6, and the fact that this is minus, I'm going to rearrange this. So I took out the 1/6 and I rearranged this since it's positive, put it first, minus ln absolute value of x plus c. Because it's a minus sign, what do we do? If it's ln's, divide. So it's going to become 1/6 ln absolute value x minus 6 over x plus c. And that is how you integrate and using partial fractions. Okay, so it's a question that requires some work, but this was worth, all this was worth 4 points. And if you were able to do this correctly, you would have been able to get hopefully 9 out of 9 points. Alright guys, thank you for watching. Hope it helped. Let me know how it went.